For decades, Linux gaming felt like a distant dream, a niche hobby reserved for enthusiasts willing to tweak configuration files, compile libraries, and accept that most blockbuster titles would simply never run. Windows was the uncontested king of PC gaming, not because Linux was technically incapable, but because the ecosystem was closed, fragmented, and commercially ignored. Then Proton arrived, and quietly, almost invisibly at first, it began to rewrite the rules. Today, Linux gaming is no longer defined by what it cannot do, but by how fast it is closing the gap, and in some cases surpassing expectations. Proton's legacy is not just about compatibility, it is about redefining what a gaming platform even means, and its future points toward a world where operating systems matter less than ever before. To understand why Proton changes everything, you have to understand the problem it solved. PC gaming was built around Windows APIs, especially DirectX. Game engines, middleware, launchers, DRM systems, and anti-cheat software were all deeply tied to Microsoft's ecosystem. Linux, despite being powerful, open, and efficient, was effectively locked out. Native Linux ports existed, but they were rare, often outdated, and frequently abandoned after launch. Gamers were forced to dual boot or rely on virtual machines, both of which added friction and compromised performance. Wine existed as a compatibility layer, but it was inconsistent, complex to configure, and unpredictable for modern AAA games. Linux gaming wasn't impossible, it was exhausting. Proton changed that by doing something deceptively simple. It made Windows games just work. Built on Wine but heavily modified and optimized by Valve. Proton abstracted away complexity and integrated deeply with Steam. Instead of manually configuring prefixes, DLL overrides, and registry hacks, users could click, install, and play. Behind the scenes, Proton translated Windows system calls into Linux equivalents, converted DirectX calls into Vulkan through DXVK, and later VKD3D, and handled edge cases that previously broke games entirely. For the first time, Linux gaming felt normal. Valve's involvement is a crucial part of Proton's story. This wasn't a community experiment living on GitHub alone. It was backed by a major industry player with a vested interest in breaking Windows' monopoly. Valve had already seen the risks of platform dependency during Windows 8's push toward a lockdown app store. Proton was not charity, it was strategy. By making Linux viable for gaming, Valve ensured Steam could survive independently of Microsoft's long-term decisions. That strategic motivation gave Proton something most Linux gaming efforts lacked: sustained funding, dedicated engineers, and long-term vision. The Steam Deck accelerated everything. When Valve launched a Linux-based handheld and declared it compatible with the vast majority of the Steam library, Proton went from a niche feature to a core product requirement. Compatibility was no longer optional, it was mission-critical. Every Proton update suddenly mattered to millions of users, not just desktop Linux gamers. This pressure forced rapid iteration, aggressive bug fixing, and unprecedented collaboration with upstream projects like Mesa, the Linux kernel, and Vulkan drivers. Linux graphics performance improved dramatically, not just for gaming, but for all GPU workloads. Proton's legacy is visible in numbers. Thousands of games that never had Linux versions now run flawlessly. Day one compatibility for major releases, once unthinkable, is now common. Performance gaps between Windows and Linux have narrowed to the point where benchmarks are often within a few percentage points, and sometimes Linux even wins due to lower OS overhead and better scheduling. Shader compilation stutter, once a major problem, has been mitigated through pre-catching and pipeline improvements. For the average gamer, Linux no longer feels like a compromise. But Proton did more than translate APIs, it changed developer behavior. Studios that once ignored Linux entirely now test their games on Proton, even if they never ship a native build. Anti-cheat vendors like Easy Anti-Cheat and BattlEye added Proton and Wine support, something that seemed impossible just a few years ago. Middleware providers began to consider Vulkan-first pipelines instead of DirectX-only designs. The existence of Proton forced the industry to acknowledge that Windows was not the only path forward. This shift has philosophical implications. Traditionally, compatibility layers were seen as hacks, temporary bridges, until native support arrived. Proton inverted that relationship. Instead of waiting for native ports, Proton became the primary solution, and native builds became optional. In many cases, Proton versions outperform poorly maintained native Linux ports, leading to the ironic reality where the Windows version of a game running through Proton is the best way to play on Linux. This challenges long-held assumptions about purity versus practicality in open-source communities. Looking forward, the future of compatibility is about convergence. Vulkan is central to this vision. As more engines adopt Vulkan, or Vulkan-like abstractions internally, the need for heavy translation diminishes. DXVK already demonstrates how efficiently DirectX 11 can map to Vulkan, and VKD3D continues to improve DirectX 12 support. As these layers mature, performance penalties shrink further, and edge cases disappear. In the long term, the distinction between native and translated graphics pipelines may become irrelevant. Another major frontier is kernel-level optimization. Linux's scheduler, memory management, and I/O subsystems have evolved rapidly in response to gaming workloads. Features like Futex, to ES-Sync, and improved CPU frequency scaling directly benefit games running through Proton. These improvements are not Proton-specific, they uplift the entire Linux ecosystem. In contrast, Windows optimization is increasingly opaque and controlled by Microsoft's priorities. Linux offers transparency and adaptability, which becomes more valuable as workloads grow more complex. The role of AI-driven tooling cannot be ignored. Automated compatibility testing, crash analysis, and regression detection are becoming more sophisticated. Proton's development increasingly relies on telemetry and large-scale testing across diverse hardware configurations. This allows issues to be identified and resolved faster than traditional QA pipelines. As AI-assisted debugging matures, compatibility layers could adapt dynamically to specific games, GPUs, or CPUs, optimizing behavior in real time. This kind of adaptability is far easier in an open ecosystem than in closed proprietary systems. Game preservation is another underappreciated consequence of Proton's rise. Older Windows games, abandoned by developers and incompatible with modern Windows versions, often run better on Linux through Proton than on Windows itself. This turns Linux into a de facto preservation platform, capable of running decades of PC gaming history. As Windows deprecates, APIs, and enforces new security models, compatibility with legacy software becomes fragile. Proton, ironically, may become the safest way to keep old Windows games alive. The future also points toward platform abstraction beyond Linux. Proton's philosophy could extend to other Unix-like systems, cloud gaming environments, and even non-traditional devices. As long as there is a Vulkan-capable GPU and a POSIX-like kernel, the barrier to running PC games continues to fall. This undermines the idea that games belong to a single operating system. Instead, they become portable workloads, deployable anywhere with sufficient hardware. There are still challenges. Anti-cheat remains inconsistent. Some kernel-level DRM systems resist compatibility, and new Windows APIs occasionally introduce friction. But the trajectory is clear. Each year, the list of unsupported games shrinks. Each year, performance improves. Each year, Linux gaming feels less like an experiment and more like a first-class experience. Proton's most profound impact may be psychological. It changed expectations. Linux users no longer ask whether a game has a native port, they ask whether it works on Proton, and the answer is usually yes. Developers no longer dismiss Linux as irrelevant, they see it as a growing, vocal, and technically capable audience. Hardware vendors increasingly test drivers against Proton workloads. The ecosystem feeds itself. In the long run, Proton contributes to a future where operating systems compete on quality, not lock-in. When applications run everywhere, users choose platforms based on performance, stability, privacy, and control. Linux excels in these areas. By removing the gaming barrier, Proton unlocks Linux for millions who previously had no reason to consider it. That is why it changes everything. Linux gaming is no longer about catching up. It is about redefining what compatibility means in a fragmented industry. Proton proved that translation layers can be fast, reliable, and scalable. It proved that open-source collaboration, backed by strategic investment, can challenge entrenched monopolies. And it proved that the future of gaming is not tied to a single OS, but to flexible, open technologies that adapt to the user, not the other way around. As Proton continues to evolve, its legacy will not just be measured in playable games, but in the collapse of artificial barriers. The idea that a game belongs to Windows is slowly fading. In its place is a more powerful concept. Games belong to players, and the platform should get out of the way. Proton didn't just redefine Linux gaming. It redefined gaming itself.